amazing people, students, and all the lovers of chemistry out there. I'm super excited to be here with you on today's video, which happens to be the second episode in our series of knowing how to name organic compounds. And today we want to talk about something that is very interesting. We want to talk about the concept of understanding the carbon chain. So without wasting time, let's get into what we have for today. Now, before we talk about anything, it is important to know what the carbon chain is. Now, remember, we said earlier on that organic compounds are compounds that have carbon as the main foundational structure inside of them. Now, one of the characteristics of carbon you must know is that carbon is able to form multiple bonds, both with itself and with other atoms. Now, when carbon forms multiple bonds with itself, it can form bonds that look something like this. Now you can see on the screen right now, I have the diagram of a chain because there is a continuous repetition of carbon atoms. So when this happens, we say a hydrocarbon has been formed. Now that brings us to the concept of knowing how to identify the longest carbon chain, which we also call the parent chain in organic chemistry. Now in organic chemistry, the parent chain is the longest continuous chain of carbon atoms, and it forms the base name of the compound. Now that we have that out of the way, let's proceed into the next thing that we have. If you know what a parent chain is, then you also need to know how to spot it or identify it whenever you see it. There are a number of ways that come into play when you want to spot or identify the parent chain or the parent carbon chain. The first thing you need to do is to look out for the longest and straight or slightly curved line of carbon atoms. And then you also need to know that it doesn't have to be in a straight line. It just has to be uninterrupted. Now, here is one example that I have over here. I have this molecule over here, and then if I want to identify the longest continuous chain, there are two ways that I can do that. I can start counting from the left-hand side and give this guy over here carbon number 1, carbon number 2, carbon number 3, carbon number 4, and carbon number 5. Or I can go another way, and from here I can start numbering, saying carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5. Whichever way I number it, I just have to make sure that I get the longest number of carbon atoms in the chain. So you can see the longest chain here contains 5 carbon atoms. And in organic chemistry, when we want to name compounds, the number 5 has the name pent. That is the name with which we identify the number 5. So the parent name of the chain becomes pentane, because from the word pent, 5 is identified, and from the word ane, it shows that it is an alkane. And alkanes are hydrocarbons that have single bonds throughout in their structure, and in this case, what we have here throughout are single bonds. So here is a pro tip for you to bear in mind. Always choose the longest possible chain, even if it turns a corner. You can see over here, when we started counting, we turned in a corner. We started from the top and then we moved sideways to the right direction. So now that we have talked about how to spot and identify the longest carbon chain, it is time to talk a bit about some of the names with which we identify the number of carbons in the parent chain. And that brings us to the concept of naming straight chain alkanes. Now, it is important for you to know that alkanes are hydrocarbons that have only single bonds. Now we're going to get into the concept of single bonds and multiple bonds, okay? But let's start off with the basics. Alkanes are hydrocarbons that have single bonds, and straight chain alkanes are the easiest to name. Now in a case where you have just one carbon atom, it is called methane. One carbon atom has this and then 4 hydrogen atoms attached to it. In this case, what we do is to identify the number of carbon atoms 1, and 1 is identified by the word meth, meth, And since it is an alkane, it will have the suffix ane. When we join the two of them together, it becomes methane, and that's what gives us the name methane. And its formula is CH4, because you can see over here there is one carbon atom and four hydrogen atoms, which give us CH4. I'm sure this lesson is being absolutely educative for you. If it is, please do me a favor by liking, subscribing, and turning on the notification bell icon, so when more videos like this come out, you'd be the first to be notified. All right, let's proceed ahead. When we have two carbon atoms, we call it ethane, because two carbon atoms are identified by the prefix ETH. ETH identifies two carbon atoms, and the suffix ANE shows that it's an alkane. When you add the two of them together, what you arrive at is ethane. ETHANE over here, and its molecular formula is C2H6. So now let's draw the structure. To draw the structure of ethane, what we have is two carbon atoms, and then we have hydrogen atoms attached to all the vacant positions. So now that I've shown you the structure of ethane, let's count the number of carbon atoms. We have 1 and we have 2. So that gives us C2. And then we have 1, 2, 3, 4, 5, 6 carbon with 6 hydrogen atoms, C2H6. Same thing goes for all the remaining numbers. For 3 carbon atoms, we have propane. 4 carbon atoms, we have butane. 5, 6, 7, and 8, we have pentane, hexane, heptane, and octane. I could go on and on and on and on, but then these are some of the names that belong to specific numbers of carbon atoms in a hydrocarbon. Now, let's talk about this example. We have an example on the screen right now that shows a molecular structure, and this is the structure we have. What do we do to name this structure? First things first, let's identify the longest continuous chain. We can start counting from the left. If we do, we have 1, 2, 3, 4, and 5 carbon atoms. If we start counting from the right, we will still have 1, 2, 3, 4, and 5 carbon atoms. 5 carbon atoms gives the prefix PENT, pent. And is it an alkane, an alkene, or an alkyne? It is an alkane because there are only single bonds throughout the structure. If you check this out, we have 1, 2, 3, 4, 5. And here is what the structure looks like. You can see over here we have CH3. So the H will be scattered all around this carbon atom. And then we have the structure of this molecule like this. So this is a more detailed illustration of the structure of this molecule. Now you can see throughout the structure all we have are single bonds. So that shows that it is an alkane. And when it is an alkane, we use the suffix A and E. So when we add the two of them together, that gives us the name pentane. I'm sure you can see how each and every one of these steps are being carried out. So now that we have named this, let's see if we can move into another concept. So far, so good. The hydrocarbons and organic compounds that we have been naming are compounds that have straight chain. Let's talk about the concept where we have branched chains. Now, what is a branched chain? First of all, a branch is a group of carbon atoms attached to the main chain, and they are also called substituents. Now, look at this. For instance, if I have 1, 2, 3, 4 carbon atoms, and then I have, hydrogen atoms attached to each of them, and then over here I have, let's say, CH3, and then the rest of it is occupied by hydrogen atoms. Now, if I ask you to identify for me the longest continuous chain, there are two ways you can do that. You can start counting from here and say 1, 2, 3, 4. Or you can start counting from here and you say 1, 2, 3, 4. Or you can start counting from here and you say 1, 2, 3, and 4. Whichever way you count, the longest continuous chain is going to be 4 carbon atoms, which gives us the prefix BUT. Now, there's something I want you to take note of. When you are counting the longest chain, there is a carbon atom that is not part of that main chain. For instance, when we started counting from over here, we gave this one number 1, we gave this one number 2 over here, number 3, and number 4. If you notice, this guy over here was not counted, and because he was not part of the main chain that was counted, it becomes a substituent, and a substituent is also called a branch. So in cases where you have a branch, we want to know how you can identify and name them. So the first and most common type of branch or substituent is called a CH3. This is called a methyl group. In the example that I just gave, where you have CH3, CH2, and then CH, and then you have CH3. You can see if we start counting from here, 1, 2, 3, and then 4. This guy over here was not counted as the main or as part of the main chain. He doesn't have any number, so he becomes a branch. And what kind of branch, or what is the name of the branch? It is CH3, which is called methyl. And this is one very common type of branch that we have in naming organic compounds, and we're going to be looking at more examples. So here are some steps to name branched alkanes or alkanes that have a branch. The first thing to do is to identify the longest chain. When you have done that successfully, the next thing you need to do is to number the chain from the end that is nearest to the branch. Now, here is what we mean. If we have 1, 2, 3, 4, and then we have a branch over here, CH3, and then we have CH2, CH3, CH, and then CH3. All of them, bonded to each other. If we want to identify the longest chain, we can start counting from here, 1, 2, 3, 4. That will give us 4 carbon atoms. But now, it is not just about identifying the longest chain. It is also about counting from the point that gives the lowest number to this branch. Now, since this is the branch, we can either start counting from the left or we can start counting from the right. If we start counting from the left, this branch here will have the number 3. But if we start counting from the right, this branch here will have the number 1, 2. It will have the number 2. So that means instead of counting from left to right, we're going to count from the right to the left because we are counting from the end that is nearest to the branch. So having done that, the next step to do is to name and locate the branch. And then you combine everything together. You number the branch, you give the branch its name, and then you put the parent name. We've talked about these steps. Now let's put them into use by solving some examples. Example number 1. So we have this molecule on the screen right now. Our first step is to identify the longest continuous chain. So how do we do that? We can start counting from here. We have carbon number 1, carbon number 2, carbon number 3, and carbon number 4. If we count this way, we have 4 carbon atoms, which has the parent name BUT. Now, are there any branches or is there any carbon atom that is not part of the parent chain? Yes, over here. And what is it? CH3, which gives us methyl. Now, before we go with this counting pattern, it is important to know whether it is the part that is closest to the nearest end. Now, here is what we mean. We started counting from the left to the right, and this methyl was placed on carbon number 2. If we start counting from the right to the left, this methyl over here will have the number 3. Here's what we mean. This will be 1, 2, 3, 4. So we want to count in such a way that our methyl group will have the lowest number possible. So we have to count from left to right instead of counting from right to left. I'm sure you saw how that was done. So now that we have counted, let's recount it again. Carbon number 1, carbon number 2, number 3, and number 4. So now let's identify the longest parent chain. 4 carbon atoms gives us BUT as the prefix. Now, are there any substituents? Yes, over here. And it is on carbon number 2. So we have 2-methyl as the name of the substituent. And then it is an alkane because there are only single bonds throughout the structure. So it becomes BUT plus ANE. So now we add the name of the substituent, which is 2-methyl, and then we add the parent name, which is butane. So the name of this compound is 2-methyl butane. Let's do another example and see what we will get. Before we do that, here are some common mistakes that students usually make whenever they want to name organic compounds. The first mistake is that they choose the wrong chain. Now, in order to fix that mistake, it is always important to count all possible chains and pick the longest one. Count all the possible directions from which you can count and pick the one that is longest. The second mistake is that they number from the wrong end. You saw the previous example that we did where we showed 2 possibilities of counting, and then if we counted from left to right, our carbon that has the methyl group will have number 2, and if we counted from right to left, the carbon that has the methyl group will have number 3. So we had to count from left to right. Students make that mistake by numbering from the wrong end. So it is important to start numbering from the end closest to the branch or the double and triple bond. We'll talk about the double and triple bond later on in the next videos in this series. Mistake number 3 is forgetting to include all the branches. It is important for you to carefully check each carbon for side groups. So now that we have done that, let's move on to the next thing we have. So here is this example over here. We want to name this compound. So step number 1, let's identify the longest possible chain. Now we can start counting from here. We have carbon number 1, carbon number 2, carbon number 3, and carbon number 4. Is it the longest possible chain? Let's find out. Instead of counting this way, let's see if we can count another way to obtain a longer possible carbon chain. So if we start counting from the left end instead, we have carbon number 1, carbon number 2, carbon number 3, carbon number 4, and carbon number 5. 5 is greater than 4, which means we'll give preference to this counting method of left to right. If we have 5 carbon atoms, that gives us the prefix PENT, pent. That shows us that we have the parent chain to be pent, or 5 carbon atoms in the parent chain. The next thing to do is to count in such a way that the substituent or the branch will have the lowest number possible. So now, counting from left to right, this guy is on carbon number 3. If we count from right to left, this guy will also be on carbon number 3. So whichever way we want to count, either from right to left or left to right, is absolutely cool. So now let's identify the substituent and give it a name. We have the substituent to be CH3, which is over here because it's not part of the parent chain. And the name of CH3 is methyl. Now, having done this, let's identify the number upon which that methyl is placed. It is placed on carbon number 3. So to identify that methyl group, we say 3-methyl. What is the next thing to do? It is important to name the parent chain. We have pent, and we also have the class to be an alkane because only single bonds are present in the entire molecule. So that gives us PENT, pent, plus ANE. So that gives us the complete name to be 3-methyl pentane. I'm sure you saw how that was done and you enjoyed every bit of how this was carried out. Alright, now, so here is a quick recap activity I'd like you to do. Here is this compound on the screen right now. I want you to name it. Carry out all the steps that I showed you in naming branched alkanes, and please comment the right name in the comment section where I'll be waiting to receive your answers. So at this point, we're done with this video. I'd like you to go over it, check out any things you did not understand, and please let me know in the comment section if there's anything you'd want me to clarify, and I'd be more than happy to do that. Next up, we're going to be talking about classifying bonds, talking about alkanes, alkenes, and alkynes. Up until then, it's bye for now. I'm so glad you stuck around till the end of this video. My name is David, by the way, and all I do here is to take the mystery out of chemistry so chemi can make history. I will see you in the next video.